Hi everyone, my name is Sina Javankhoshdel and I'm the product manager of Slide2 and Slide3 programs. In this episode, I'm going to talk about sensitivity and statistical features in the Slide3 software. There are a lot of cases that users require to do sensitivity analysis on their soil properties. Slide3 gives you this option to carry out sensitivity analysis for a range of input parameters. Also, in addition to that, to calculate probability of failure and carry out probabilistic analysis, Slide3 has different features, including the traditional Monte Carlo and Latin hypercube simulations and the more advanced one, which is the stochastic response surface method. We developed these features to help our users to carry out probabilistic analysis faster and in a more accurate way. In this episode, I'm going to show you an example of sensitivity analysis for material properties, also a probabilistic analysis carried out using a Slide3 software. Let's look at the example. Let's look at an example here. In this example, I'll show you the sensitivity analysis in option in a Slide3. So if we go to project settings in the statistics menu, this is a new feature that we have called sensitivity analysis. We have probabilistic analysis as well, but let's look at the sensitivity analysis first. If you go to the material properties menu, we have a generalized anisotropic material, which has a base material and bedding material. And we have an anisotropic surface as well. So in this example, we want to know how sensitive is my material and my factor of safety to the properties of bedding and base. For that, in the statistics menu, for the bedding and base, we define the mean and a range for my cohesion and friction angle of bedding and the base material. We did a sensitivity analysis, and if we look at the sensitivity plot, you can see that for the Yambu method, you can pick what parameter you want to look at, like the effect of one parameter on the factor of safety. Keep in mind, in the sensitivity analysis, we change one parameter while other parameters are constant, and again change the other one while the other ones are constant. So if we look at the, for example, friction angle of bedding, you can see that as the friction angle goes up from 5 degrees to 15, factor of safety changes from 0.9 to around 1.5. So it's a big difference. So this parameter has a big influence on our results. If you look at the sensitivity of all parameters, you can see that here the red one is the bedding of friction angle, and you can see that it has more effect on factor of safety compared to the other ones. Since they have different units, we just show the percentage of range of each parameter on the factor of safety. So this is about sensitivity analysis. We have probabilistic analysis option in a Slide3 as well. So this one, if we go to the project settings, you can see that in the statistics menu, we use the stochastic response surface, which is very fast approach for especially Slide3 models because the computation time is long and response surface is very handy for these types of models. We have global minimum, overall slope, and multiple minimum options. For this example, we did global minimum. So we assume that we only have one slip surface, and in each realization, we just change the properties for that slip surface. And if we look at the scatter plot for the factor of safety, it will look like this. So this is the scatter plot for Yambu. And probability of failure is 13.8%. I did the same example, but with the overall slope option, which in each realization, we calculate the new slip surface and new factor of safety. And for this one, probability of failure dropped to 5.6, which is more accurate since in each realization, your properties are changing and your probability of failure and factor of safety will change as well. So if we go to statistics and material statistics, for these two examples, I defined the shale material and the generalized anisotropic materials with the COV function. So we define the COV of the shear strength with a log normal distribution, and this is the coefficient of variation instead of separately defining the input parameters as variables, just the shear strength. So that's another way of defining statistical parameters as well. This concludes our episode on sensitivity and probabilistic analysis in slide 3. If you have any questions or comments, please feel free to leave them in the comment section below. Also, don't forget to subscribe. Thank you.